it passes through the F. And the norm of the convex lens is, this is the action of the convex lens. If you draw it, and this diagram should be drawn very carefully, you will see an interesting thing in it. Okay. So this is ray number 1. Started from the head of the object, moved parallel to the principal axis. After passing through the convex lens, it passed to the focal point on the other side of the lens. Simple. Now I will draw the second ray, and that also starts from the head of the object, and it passes through the optical center and it goes undeviated. Its path do not change. So very simple. Just join them. My diagram is not that good, but if you are drawn on the copy, that will be very good. Let me show you that. These two rays will become parallel to each other. When they become parallel to each other, it means they do not intersect here. So it means if you put an object on F in front of a convex lens, its image will be not formed. There will be no image. Because these two rays are parallel to each other, so obviously they are not going to intersect each other. So no image is formed. If you will draw it on the copy it will be very good. Here, it does not look that good. No image will be formed. If somebody has drawn with a ballpoint, I can show that. Just tell me if it's clear. If it's clear, this diagram is clear, it's visible. So you can see when I place the object on F, the rays become parallel. So they will not intersect each other. So no image will be formed. Okay? So this is the diagram. Okay, G. So you understand this? No image is formed. Okay. And then I can erase it. Okay. Now suppose let's move this thing further. Let's move the object, let's place the object between the optical center and the focal point. Okay, if I place the object between the F and the optical center, let's see what happens, where the image will be formed. Okay. So the distance of the object right now from the convex lens is less than the focal length. It's a very important case. It's a famous case. So let's see what happens. So we will start from the ray number 1, which starts from the head of the object, and it moves parallel to the principal axis. And after passing through the lens, it will pass through the F on the other side. It will pass through the F on the other side. Okay? So you see, this is ray number 1. It started from the head of the object, moved parallel to the principal axis, and on the other side, because it's a convex lens, it will be bended and it will be focused on F. It will pass through the F. Then I will draw the second ray, which starts from the head of the object, passes through the optical center, goes undeviated. So let's draw this. it's not that good. But when you draw it on your copy, I will show you the drawing on the copy also. These two rays on this side of the lens, they are going away from each other. They will never intersect on this side. But if I prolong them behind the mirror, if I prolong them behind the mirror, you see, they will intersect. If you prolong them behind the mirror, they will intersect. Now look at here. The object and the image are on the same side. The image formed is not by the intersection of actual light rays. The image you can only see when you see through the lens. Otherwise, if you look at from here, you will not be able to see the image. This is the magnifying glass. You see the image only when you see through the lens. Okay?
So the image is virtual?
This image is called virtual image. This image is upright. We use two words. We say upright. And we also say this is erect. The image is upright. Or you say image is erect. And you can see the size of the image. Very large. The image is magnified. If I put the object between the optical center and the focal point in front of a convex lens, the convex lens will behave like a magnifying glass. The image formed will be on the same side of the lens. The image formed will be magnified. The image formed will be virtual. The image formed will be upright, or we say erect. You understand? This is magnifying glass. And you must have noticed, whenever you use magnifying glass, have you noticed this? The magnifying glass is not used like this. If this is the magnifying glass, and this is the thing whose image you want, it is not placed here. The magnifying is always placed very close to that thing. Why? Because we want to put the object inside the focal length. That's why the object and the magnifying glass are very close to each other. And the image is on the same side. The image formed is magnified. That's why we use the magnifying glass. Have you ever gone to a palmist? Palmist? You understand palmist?
Yes, sir.
Okay, so the palmist also use magnifying glass. Okay? So you understand this?
Yes, sir.
Have you drawn that diagram? So we can show it on the camera also. Is it clear?
Yes.
It's visible? This is that diagram. When I put the object between F and the optical center, here the rays are spreading out. So on this side of the lens, they will never intersect each other. But when I prolong these rays behind these dotted lines, so they intersect each other here. So the image formed will be here. This image is virtual, this image is magnified, this image is erect, this image is upright. You understand?
Yes, sir.
And this is the magnifying glass. Okay? This is the magnifying glass. Okay? So, thank you. The next thing, your teacher is not outside.
She is.
Oh, she is. Okay, thank you very much. We have one more diagram to understand. That will be a concave lens. So thank you very much. Today is 30th September 2020. Right now I am in the 10th Cambridge class. We were studying physics. We were learning how to locate the image in the lenses. So thank you very much. God bless you all.